In this A-level mechanics problem, a particle P, which has mass 2.5 kilograms, is at rest on a smooth inclined plane at an angle of 25 degrees to the horizontal. Now, it's connected to a particle Q, which has mass 1.5 kilograms, by a light inextensible string which passes over a fixed smooth pulley. Q is hanging freely 0.7 meters above the ground with the string taut when the system is released. Using this information, we need to find the acceleration of the system, the tension in the string, and the speed of Q when it hits the ground. The first thing we're going to do is to label our diagram with the forces that we're going to need to solve this problem. Let's start with particle P. Its mass is 2.5 kilograms, so it's going to have a force due to gravity of 2.5 G. Now for G in this question, we're going to use 9.8. It's also got the reaction force, which is perpendicular to the plane, which we're going to call R. Then looking at particle Q, its mass is 1.5, so it's got a downwards force of 1.5 G. And then both bits of string, each side of the pulley, will have a tension T pulling towards the pulley. Note that these are equal to each other, which is why we've given them the same letter. Now that we've got this, we can start solving our problem. Let's resolve for particle Q first. So we know from the problem that Q is going to be going downwards on this because we've been asked how long will it take to hit the floor. So let's resolve with the positive forces going down. So forces acting on Q, we've got the 1.5 G going downwards, we've got a T going upwards, pulling it back. So the total force is 1.5 G minus T. We're going to use the equation F equals ma here. So the right-hand side is going to be the mass of 1.5 times by A, which we don't know yet. We're going to do the same thing to P now. So P has got T pulling it up the slope. Now it's got part of the 2.5 G pulling it back down. But because the 2.5 G is acting vertically downwards, it's not acting parallel to the slope, we're going to need to take a component of this. So when we've got our downwards force, to work out the part parallel to the slope, we're going to use sine of 25. If you're unsure where this has come from, think of the triangles you can make where that force line is the hypotenuse. And you'll soon see that the bit that we need that is parallel to the slope would be found with sine 25. So the force on P pulling up the slope is T minus 1.5 G sine 25. Again, this is going to equal mass times acceleration, so it's going to equal 2.5 times A. Good way to start here, because we've got minus T in the Q bit and we've got T on the P part, if we add the P and Q together, those T's are going to cancel. So we'll get 1.5 G minus 1.5 G sine 25. And that's going to equal 1.5A plus 2.5A, which is 4A. Using G equal to 9.8, working out sine 25 on the calculator, we get that 4A is equal to 4.346. So A, the acceleration of our system, is 1.09 meters per second squared. We can now use this to work out the tension. I'm going to use Q just because it's the simpler of the two equations, but it doesn't really matter. So if we put our acceleration back into our original equation for Q, using G is equal to 9.8, we get 1.5 G minus T is equal to 1.5 times 1.09. Rearranging this, we get T is equal to 14.7 from the 1.5 G minus 1.635. So that equals 13.07 newtons. The final part of our question is to work out the final velocity of Q at the point where it hits the ground. And to do this, we're assuming that P doesn't reach the pulley. So Q is moving under the forces of our diagram for the whole of the movement. We're going to use some Suvat equations for this because we're looking for the final velocity, which we're going to call V. We know the initial velocity is 0 because we were told it's stationary to start with. We know S, the distance travelled, that's the 0.7 meters down to the ground. And we've just worked out the acceleration of the system, which is 1.09. So we need a CVAT equation which contains v, u, s and a. We're going to use v squared equals u squared plus 2as. Substituting our values into there, we get 0 plus 2 times 1.09 times 0.7. So v squared is equal to 1.52. Square rooting this gives us our final velocity of 1.23 meters per second. One thing to note here is that I used the value for the acceleration in my calculator, the non-rounded version, which is why I got 1.23. If you stuck 1.09 in, you get a very slightly different answer. That's perfectly fine. If you've enjoyed this video, don't forget to subscribe or check out more of my videos by clicking on the links here.